Welcome to Climate, the MP4 narrated PowerPoint video. Today's objective is going to be to define what climate is and also to identify what kind of variables and factors go into making a particular climate in a particular place on the Earth. So let's take a look at two different words, weather versus climate. These two terms are often very misunderstood and we actually interchange them too many times. Weather is the condition of the atmosphere at a particular place and time. Weather conditions vary from day to day and includes things like temperature, humidity, precipitation, wind, and many more. Now, climate, on the other hand, is the average weather condition in an area over a long period of time. Climate's mostly determined by two factors. One, temperature, and the other is precipitation. So different parts of the world have different types of climate. The question is why? Besides temperature and precipitation, other factors that affect climate are latitude, wind patterns, mountains, large bodies of water, and also ocean currents. Latitude, the distance north or south of the equator measured in degrees. The further away from the equator, the colder the temperature. It's because of the amount of direct solar energy each place receives from the sun. As you can take a look at in this diagram, the Earth's tilt affects how much solar energy the area receives. If North America is tilted towards the sun, of course they're in summer. If it's tilted away from the sun, they're in winter. And in between we have spring and fall. Likewise, for our friends down in Australia, it's the exact same situation. If the southern hemisphere is tilted towards the sun, they're in summer. If it's away from the sun, it's winter, and in between, spring and fall. Along with latitude, we also have what's called prevailing winds. Winds that blow from mainly one direction affect the amount of precipitation a certain region receives. Winds blowing across land tends to be dry. Winds blowing across bodies of water tend to absorb moisture, and of course, that affects the climate. Mountains can also influence an area's climate by affecting temperature and precipitation. A mountain's higher elevation will cause a drop in temperature at the top than at the bottom. Of course, Mount Kilimanjaro is a great example. It's the tallest mountain in Africa, and it's snow-covered year-round, even though it's at the equator. Mountains can also affect the climate of a region by influencing how much rain a specific area of that mountain gets. Look at it. The windward side of this mountain is going to be receiving a lot more precipitation. Cool air cannot hold moisture compared to the warmer air. So when the prevailing winds blow across one side of the mountain, voila, we have precipitation. After the air crosses the top of the mountain, the air begins to sink and warm, and as it warms, it absorbs moisture from that particular side. And as you can see, it causes a desert climate. Large bodies of water can cause regions near them to have moderate temperatures, but also more precipitation. Makes sense. Think about it. You have evaporation coming up off of the water, okay? And then you have moisture in the water, and as it climbs, it leads to heavy snowfalls in the winter, and this is known as lake effect snow. Now, ocean currents can also cause regions near them to have either warmer or cooler climates than they normally should have. Now, if you've ever lived, say, in South Carolina, you know where the currents come from. They come from the equator. They're warm waters bringing up warm air. And you know, if you've ever lived out in Santa Monica, California, those currents are coming from up north. So they both affect the climate. And we also have what's called climate zones. The Earth has three major climate zones: tropical, temperate, and polar. Take a look at this graphic. We actually have tropical climates that are listed in red. Then we have middle latitude climates that are in orange. And then we have polar climates, which are in blue. Within these climate zones, we have what are called biomes. They are a large region characterized by a specific type of climate and certain types of plants and animals that occupy these communities. Let's take a closer look. In fact, let's take a look at tropical zone climates. Tropical zone climates is a region surrounding the equator from 23.5 degrees north and south, typically hot temperatures except at high altitudes. Tropical zone has three major biomes: tropical rainforests, which are warm and wet. They contain the greatest number of plant and animal species, and they have thin, nutrient poor soil. We also have tropical savannas, warm and dry, tall grasses, few scattered trees, and poor soil. We also have tropical deserts, extremely dry. There are species that are adapted for little water, and the daytime can reach 50 degrees Celsius, and the nighttime temperatures can go all the way down to 20 degrees Celsius. Then we have the temperate zone, a region between the tropics and the polar zones characterized by seasonal changes. Within that temperate zone, we have 4 major biomes, the first of which is the temperate forest. It's high rainfall, warm summers, cold winters, a lot of fertile soil, deciduous trees. And then we also have temperate grasslands. Rainfall not enough for trees to grow, warm summers, cold winters, mostly fertile soils of all biomes. We also have chaparrals, cool wet winters, hot dry summers, short woody plants with thick leaves, and it also has nutrient poor soil. And then finally we have number 4, temperate deserts, cold deserts, hot days at 120 degrees Fahrenheit, low rainfall. Plants include cacti, shrubs, and thorny trees. Then we have our polar zone, the coldest average temperatures in a particular region surrounding north and south poles. The polar zone has 2 biomes. The tundra, which has long winters, almost 24 hours of night, and short, cool summers, almost 24 hours of daylight. In the summer, only a top meter of the soil thaws, and of course we know that this particular area has permafrost, areas that have permanently frozen soil. Now that's changing because the earth, of course, is warming up. Then we have taiga. It's a long, cold winter, short, warm summers. You can find moose, bear, and also rabbits. And of course conifers, pine, spruce, and fir trees, along with acidic soil within this particular biome. Of course we have what's called a microclimate, the climate of a very small area. Sometimes a small area has a different climate than the surrounding region. In this particular, they're focusing on Mount Kilimanjaro because it has a completely different climate than everything that surrounds it because of its altitude. But in other cases, like cities, they also have a microclimate. And why? Because all the buildings and pavement absorb solar energy rather than reflect it. So it's warmer. Now, there has been significant evidence that the Earth's climate has not always been as it is today. In fact, geologists have found indications that the climate has been much colder in the past. And you know this as an ice age, a period of time that ice collects in high latitudes and moves towards lower latitudes. We're going to take a look at a couple different theories. One theory that was proposed by Yugoslavian scientists is that every 100,000 years the Earth's orbit changes from an elliptical to more circular orbit, and of course the tilt of the Earth also changes, and in return this changes the Earth's overall climate. Now, along with the Milankovitch theory, there's also a theory that was set forth by a German scientist by the name of Alfred Wegener, and he actually said that Pangaea was a supercontinent, and at some point the continent broke apart and the continents drifted to their current position and thus changed the climate on each particular landmass. Now, along with small, methodical, slow-moving processes like continental drift, there's also catastrophic events such as volcanic eruptions that can influence the climate in a particular location. Of course, we know this from volcanoes and also asteroid strikes, as you can see the giant crater that's actually shown in the picture above. So that's today's lesson. I hope you learned a lot. If you need to go back, rewatch the video, do so, and then complete your questions. Have a great day.